Hello everyone. So here we're going to work with a hangers problem. We're going to say we have 35 degrees and 42 degrees on the two different hangers. We're going to call the left one and the blue one. We're going to call that number one. So it's going to have tension one, and it's going to have two components of that tension. So the y component of tension one, so T1y, and the x component of tension one, which is T1x. And the ratio of T1y and T1x, the tangent of that is 35 degrees. And I have the same thing with 42 degrees in red on the other side for the second cable. So, and we have T0 at the bottom there, which is the tension of the little rope connecting from where the two different ropes meet to where the package is being hung. All right, so first thing I'm going to do is I'm going to kind of calculate the force of gravity acting down on this object. So the force of this object is going to be mass times acceleration. So force of gravity equals mass times acceleration. So actually I'm going to zoom in here. So force of gravity equals mass times acceleration, which is just going to be G equals ma equals, and that's going to be 100 kilograms times 9.81 meters per second, which is 981 newtons, which means that the force of gravity pulling down on this object down that way is 981 newtons. 981 newtons, which means the tension in here is also 981 newtons. So T0 is equal to 981 newtons. We also know that the tension, or the tension which is keeping that object in place, that tension is being then split and shared, maybe equally, maybe not equally, by these two vertical components of the tension of those two cables up above, right? So this 981 is then shared by T2y and T1y. So we can write the tension 0 for the initial tension, 981 meters, not meters, newtons, is equal to T1y plus T2y, right? So the y components of the two tensions of the cables is being split, right? We're adding them, and that's equal to the initial kind of tension we have at the bottom there. Awesome. Okay, well, what else can we glean from our diagram over here? Maybe zoom out a little bit. We know that this is not in motion, right? It's not swinging left to right. So we know that this here and here, the x kind of component of these two tensions is equal, right? So the tension left and the tension right are equal to each other. So we know that if tension 1x is equal to tension 2x, tension 2x, then there's no motion, which is awesome. Okay, what else can we get? Well, we know that, we know we can work with some angles here. Maybe saying that, let's see, we have the tangent. I want to work in blue. We'll go with the number one side first. We have the tangent of 35 is equal to opposite over adjacent, which is T1y over T1x. All right, we know that T1x equals T2x, so we can go ahead and kind of rearrange these, say that T1x is equal to T1y over tangent 35, right, and that's equal to T2y, or not T2y, T2x, right? We're still working in the x component of both of these. So I hope that makes sense. We just kind of swap these two here and put that back under, and then we said, okay, because we know this, then it's equal to that. Okay, we can do the exact same thing. I'll do it in red for the y component. So the tangent of 42 is equal to T2y, which is the opposite side, over T2x, which is the horizontal component. Then we can rearrange those to say that T2y, which I'm just going to leave kind of over there, is going to be equal to, T2x, I'm going to leave over there, is equal to T2y over the tangent of 42. Okay, so that's the tangent of 42, and we know that these two quantities are actually equal to each other. So I'm going to go ahead and move back to my white and say that now we know that, well, I'll zoom in and do it over here. Okay, so we know that t1y over the tangent 35 is equal to t2y over the tangent of 42. Okay. We also know that t1y is equal to 981 minus t2y, right? Because we know that from this equation up here, we can just subtract this and move it over there, subtract that, and we get it over here. We can go ahead and just substitute it right back in for t. Oops, excuse me. We can substitute, this is t, we can substitute this into here, and now we can solve. We have a bunch of constants and two variables, so we can solve. We can say 981 minus t2y over, maybe we'll multiply both sides by tangent of 35, 42, and then divide by this. So I'm just kind of switching these two, switching the positions of those two, so that's t2y. Go ahead and erase those marks. So over t2y, right? So we can decompose that function. So we have this over, and that's 1. So we have negative 981 over t2y minus 1, because t2y over t2y is 1, equals the tangent of 35 over the tangent of 42. We can add that over here. So we just get, I'll go ahead and I'll erase because I'm running out of space. So we'll just say that that gives us 98 over the tangent, 981, I'll just write it out, over t2y is equal to tangent 35 tangent 42 plus 1, that's a 42, 42 all plus 1. Alright, so and this is just a quantity, that's an integer. We can multiply by t sub, or the tension of 2y, and then divide by this quantity to get it back over, so we can solve for t2. If we do that, it ends up being t2y is equal to about 551 newtons. And we can solve it back in with this equation to just find t1y, which is equal to 429 newtons. And with that information, we can go ahead and plug it into our initial conditions we had over here, saying that the tangent of 35 is t1y over t1x, but now we know t1y, so we can find we know t1y. We know that they're equal to each other, so we can find the total tension, which is the tension in the rope, which is the tension here in the ropes all together. So not the components. We can now find the total tension. So we know that tension 1 is going to be equal to t1y over the sine of 35. Again, that's just geometry, which is going to be equal to 748 newtons. We know that t2 is going to be t2y over the sine of 42, and t2y over the sine of 42 is going to be equal to 825-ish newtons. So those are two tensions in those two ropes. Hope I didn't mumble too much, or if I made it somewhat intuitive to kind of help and follow. If not, holler at me. I'll make another video. I'll explain it in class, or we'll figure something out.